Binomial distribution. A discrete random variable x is to follow binomial distribution if its probability mass function is given by probability of x is equal to x, NCx, p raised to x, q raised to n minus x, where x varies from 0, 1, 2, 3, etc. up to n, where n is the number of trials or sample size, p is the probability of success in a single trial, and q is equal to 1 minus p is the probability of failure in a single trial, and x is the number of successes in n trials. Mean of a binomial distribution is expectation of x is equal to n into p. N is the number of trials. Variance of the binomial distribution is variance of x is equal to npq, and standard deviation is equal to square root of npq. Example, a brokerage survey reports that 30% of individual investors have used a discount broker. In a random sample of 9 individuals, what is the probability that? Question number 1. Exactly 2 of the sampled individuals have used a discount broker. Question number 2. Not more than 3 have used a discount broker. Question number 3. At least 3 of them have used a discount broker. A question is coming like that. A brokerage survey reports that 30% of the individual investors have used a discount broker. So we can divide this problem into two parts. That is 30% are using discount broker and 70% are not using discount broker. And with the problem of investors, exactly 2 of the sample individuals have used a discount broker. It is concentrated on used discount broker. So P is equal to probability that an individual investor have used a discount broker, that's equal to 0.30. Q is not using a discount broker, that is 1 minus 0.30, that is equal to 0.70. N is equal to number of trials, that is equal to 9. So we can convert, or the above problem can be converted to a binomial distribution with N is equal to 9, P is equal to 0.30 and Q is equal to 0.70. So its probability mass function is P of x is equal to 9cx 0.30 raised to x 1 minus 0.30 raised to 9 minus x, where x varies from 0, 1, 2, 3, etc. up to n, and here it is 9, that is equal to up to 9. First question, exactly 2 of the sampled individuals have used a discount broker. Exactly 2, that means the success is 2. So put x is equal to 2, we get P of 2 is equal to 9c2 into 0.30 raised to 2, 0.70 raised to 9 minus 2. 9c2 means 9 things taken 2 at a time. How many ways 9 things can be taken 2 at a time? That can be done in a different way. They can be found out by different formulae. But this is from the 2 numbers, that is 9 into 8, from the denominator starting from 1 into 2. For 0.30 raised to the whole squared, 0.70 raised to 7, that answer is 0.62656. Question number 2, not more than 3 have used a discount, not more than 3. That means it should be 3 or below 3. Below 3 means it can take either 0 or 1 or 2 or 3. So these are mutually exclusive events. By addition theorem, for finding probability of x less than or equal to 3, probability x is equal to 0 plus, probability x is equal to 1 plus, probability x is equal to 2 plus, probability of x is equal to 3. Substituting all these values in the formula, and the final answer will be 0.73. Question number C, at least 3 of them have used a discount block. At least 3 means minimum 3, that is 3 or more than 3. So more than 3 means it can be 3 or 4 or 5 or 6 or 7 or 8 or 9. So calculating all these is a tedious work. For the simplicity we can find out. We know the total probability of a distribution is 1. So 1 minus remaining, except 3 and more than 3, the remaining is 0, 1 and 2. So you can subtract all these values, we get answer 0.537. For the calculation, 1 minus, put x is equal to 0, we get 9c0, 0.3 raised to 0, 0.70 raised to 9 minus 0. 9c0 is always 1, whatever it may be, nc0, 7c0, it is always 1, and 0.3 something raised to 0 is always 1, 0.70 raised to 9 minus 0, that's equal to 9. Plus 9C1 means 9 things taken one at a time. So 9C1 is 9 times you can take, or simply by definition 9C1 is 9. 9 into 0.30 and 0.70 raised to h. Again 9C2, 9 things taken 2 at a time. How many times? That is 9C2. That is, we can start from 9, 9 into 8 by 1 into 2, 0.30 the whole square. Simplifying and adding all these, we get the answer is 0.537. Example 2. The incidence of an occupational disease in an industry is such that the workers have 20% chance of suffering from it. What is the probability that out of 6 workers, 4 or more will come in contact with the disease? Here also the problem, you can look at the problem. The incidence of an occupational disease in an industry is such that the workers have 20% chance of suffering from it. That is, we can divide the two parts, suffering from it, not suffering from it. And also the problem of industry is suffering from it. So we take P is equal to probability that a worker suffering from the disease is equal to 20%. 20% means 20 by 100, that's equal to 0.02. Q is equal to probability that a worker not suffering from the disease, that is 1 minus P, that is 1 minus 0.02, that is equal to 0.06, 0.08. So out of 6 workers, that is the number of trials is equal to 6, that is equal to N is equal to 6. So it follows a binomial distribution with the P of x is equal to 6cx ncx 0.02 raised to x 1 minus 0.02 raised to 6 minus x. X varies from 0, 1 to 3, etc. up to 6. So the question is 4 or more will come. That is, we take 4 or more, 4 plus 5 plus 6. That is probability x is equal to 4 plus, probability x is equal to 5 plus, probability x is equal to 6. So first of all, put x is equal to 4, we get 6c4, 0.02 raised to 4, 1 minus 0.0 raised to 6 minus 4, plus 6c5 plus etc. First of all, you have to evaluate 6c4. That is equal to 6 in from 6 onward, 4 numbers you can multiply 6 into 5 into 4 into 3, 4 divided by from the beginning 1 from the 1 into 2 into 3 into up to 4. Then simplifying again 6c5. 6c5 is always 6 and 6c6 that is always 1. So 695. Example 3. The probability that an evening college student will graduate is 0.4. Determine the probability that out of 5 students, question number 1, none, question number 2, 1, question number C, 3, at least 1 will graduate. So here also we can divide into 2 parts. Probability that evening college student will graduate is 0.4, not a graduate is 0.6. So Q is equal to 0.6. Out of 5 students, that is number of trials is equal to 5. So it follows a binomial distribution. The P of x is equal to 5cx, 0.4 raised to 6, 0.6 raised to 5 minus x, and x varies from 0, 1 to 3, etc. up to 5. Then question number 1 is none. None means no student will be a graduate. That is P of x 0, that is 5c0, 0.4 raised to 0, 0.6 raised to 5 minus 0. 5c0 is always 1 and 0.4 raised to 0 is always 1. And the remaining is 0.6 raised to 5. Simplifying, we get 0.0777 is the answer. Question number 2, 1, that is put x is equal to 1, 5c1, 0.4 raised to 1, 0.6 raised to 5 minus 1. So 5c1 is 5 into 4 into 0.6 raised to 5. So answer is 0.2592. Probability that at least 1, that is x is at least 1 means 1 or more greater than 1. That is, you have to find out P of 1 plus, P of 2 plus, etc. up to P of 5. So it is tedious work. We have to add 5 numbers. Instead of that, you know the probability total is 1. So P of 0 plus, P of 1 plus, P of 2 plus, etc. up to P of 5 is equal to 1. So if you want to find out P of 1 plus P of 5, remember that is 1 minus the remaining P of 0, we can subtract, we get 0.9223. Next, fitting of binomial distribution. So an experiment is coming, an experiment with the absolute frequencies are coming are in the problem. So what you have to, how to fit a binomial distribution? So by fitting a binomial distribution means to determine the expected or theoretical binomial frequencies against the given observed frequencies. The theoretical frequencies are obtained by multiplying the binomial probabilities by the total frequency, that's equal to capital N. To calculate the binomial probabilities, we require P. N can be determined the values of X in the data, and P is not available in the data. Find out the mean of the given frequency distribution and equate it to NP. So the data is given. You can easily find out X bar, the mean from the data. That for a frequency distribution, that is equal to sigma Fx by sigma F. So we get it with the mean of the binomial distribution NB.